What's up, guys? Welcome back to day 2 of the 5 days of decentralization. Today, we're going to be taking a look at Holochain. Holochain is a collection of application frameworks and services aimed at helping developers develop distributed applications. Holochain aims to solve a lot of blockchain scalability issues that we currently face without the use of proof of stake or proof of work. We're going to dig in and tear apart some of this technology and compare it to existing new internet type projects in the space. Let's dig in. All right, so the first thing we do is we say hc init holochain test, which actually creates a boilerplate project in the holochain test directory. Then we want to generate a list zome by saying hc generate zomes list. And we can take a look at the boilerplate code created here. And this is already given to you. This is very simple to set up. So now we have the basis for our program. Let's go ahead and get to some code. And we're starting from scratch. So right now we are importing all of the external libraries that we can use in order to interact with the HDK. So we're going to import the Zome API response types, as well as hash string, some DNA, sharing permissions, JSON serialization constructs. Here we also set up our default Zome metadata. So this defines what this Zome or library does, specifically the data types that it uses, as well as the core functions that other nodes on the Holochain network can actually execute or invoke. Here we're actually defining some links in the data. So we've defined a list data type, and we are saying that we have some children data types, such as list items that belong to this list. The big point here is that the DHT for Holochain can actually contain linked data. We also define some simple validation constructs that always return OK. However, our validation here could actually be defined that the list obeys a certain protocol or a certain type, or even maybe some permissions get enforced. But for the purposes of this demo, we're going to just have validations return OK. We are defining functions here, such as the creation of lists, adding items. We're also going to add in a simple test handler that we can execute just to sort of get a hello world result. But basically, the functions here are defining inputs, outputs, as well as the handler function that gets called. We're also going to define these list constructs using simple structs here, and this basically says this is the format of the data that we're going to pass back and forth. Here we implement the function handler for create list. So when this gets called by another node, it actually calls this function. And we basically serialize a list entry using the format that we just described, and we say HDK commit entry. We're also going to do the same thing for adding an item to a parent list, as well as getting a list. We're going to transform the data types. We also want to make sure that when we get the list, we're getting all of the linked data, which again is the list items. And we basically return that back to the client in the form of a get list response. So you've got name and a list of items. And we're also going to do a handle test here, which again, we just return hello as a string. And here we have to define a simple helper function. So this helper function is basically going to support getting information from the distributed hash table and then converting that to a specific data type. Otherwise, since Rust is a type-specific language, we would end up having to move this around. Okay, so in order to get a web interface going, Holochain does supply something called HC Web Client, which supplies a JavaScript interface to communicate with a Holochain distributed agent over a WebSocket. So we've gone ahead and cloned this, and we're running an npm install to go ahead and install all of our dependencies. Again, since this is JavaScript, we're just going to be simply using npm install. And then what we want to do is we're going to build this into a lib.js or holoclient.js file that we can use inside of our main application. So we're going to run npm run build, and that's going to go ahead and compile the JavaScript client into something that we can use in the browser. Perfect. Okay. So now, if we ls here, we've got a simple index.html, but we're actually interested in the lib directory. And that's our holoclient.js and holoclient map file. We're going to copy those into our project. Okay, so we're going to go into our UI folder, create an index.html file. And we're going to create some boilerplate code. This is supposed to be pretty minimalistic, so we're going to throw a couple of buttons in to run the test function. We're going to add the create list, and we're going to add a get list. And these functions are basically going to be the UI elements that will execute the functions that we wrote previously on our Holochain node. So now we have to wire up those buttons to actual logic. And we're actually going to set up a little bit here. This URL is the URL of our locally running node, default port 8888. And I'm going to add a utility function here just to make things a little bit neater in code. When we click the do test button, we're actually just going to execute the test method on our node and then log the data to the console. When we click create list, we're just going to execute the create list method, but we have to add the ID. We have to snag the ID first, so that's what that one's doing. And then when we get a list, we're going to take the ID from the text box that we made right there, and we're going to execute get list with that list address. And then when we add a list item, we need to snag the list ID as well as the to-do item text, and then we call add item on our node. And again, logging the data to the output. Let's go ahead and spin up our HC application here, and we're going to go ahead and run python 3-m HTTP server just to spin up a simple HTTP server. And we should be able to see our application in the browser. Okay, so we have our browser open here, and we are going to go ahead and go to HTTP localhost 8000, and we can go ahead and pop up a console window here. And now here are all of the UI elements that we created in our code, actually over here. So this is actually what's in the browser. This is running on our Python HTTP server. So if I click run test function, we should actually get some output here in the console, because this is the code that actually gets executed. We call test on our node. We have the Holochain node visible down here. So if we click run test function, we get OK hello, which indeed we have our test function here, console logging, and our test structure up here just says handle test. And if we look at handle test, it returns OK hello. And indeed, we can actually see that down here. So it does appear that we are communicating with the Holochain core from an unmodified web browser. This is just Brave, standard stuff here. So let's go ahead and try to create a list. And we can say my list. And we see that everything gets persisted back over here on our local disk. And that's actually just because we're running everything in test mode. We could run this with a persist flag, and this would cause it to be persisted to the actual DHT. Now it does return an OK with an address, and again, handle create list does return a Zoom API result with an address, and this indeed is the address of this information in the distributed hash table. So what we can actually do is we can now get that list, and yes, indeed, this returns the list with the name my list. The items array is blank. We haven't added any to-do list items yet, but indeed, this is working. Now let's test the linked data feature here. We are going to insert something into this list ID, and our to-do item, we can just say, is get milk. And we click, and it returns another address. Now, The thing to note is it added this to-do list item to the DHT. So we could actually fetch this to-do list item on our own if we wanted to. But what we really want to do is see if it actually linked anything to the list. So if we actually copy, again, our old list ID, or we just click this button here, we'll notice the items array is blank, and that's due to local caching. If we click the button again, it should bust the cache. And indeed, since it's gone out to the DHT and fetched the item, it does appear that our items are being linked appropriately, despite the fact that these have two separate addresses and could potentially be stored on two separate nodes in the DHT, so on the Holochain network. However, the library automatically takes care of linking this data. Again, this is actually why we're getting the links here, and in our data declaration up here for our Zome, we do have the links defined here. So the Holochain network automatically knows to fetch anything, all the remote data associated with this list. So that is fantastic. We were able to do that pretty quickly. Now, here's the thing. If we create a list again, we'll notice that we actually get the same address. And that's actually because this is content addressable. So a lot of the stuff on the Holochain network is deduplicated. So this means that applications that have duplicate data stored on the network, regardless of which node it came from, could actually end up having those entries condensed into one. And this ultimately keeps the amount of space required pretty low on the network, because remember, every value that we're storing is stored by the very agents of the network that are opting to dedicate their resources to running the application. And in consequence, they're compensated for that, but we still want to make sure that things are deduplicated, remain speedy, and that's one of the major scaling aspects of the Holochain network. So hopefully you were able to see what is possible with Holochain in this demo, and you know, how easy it is to run applications in an unmodified browser communicating over standard WebSockets. So the big question, what are my thoughts on Holochain versus other distributed application technologies like Elastos or Blockstack or even SafeNet? Well, I think Holochain is great in the sense that it allows you to use technologies to interact with your customers that already exist. So for example, the fact that you can communicate over a WebSocket to a Holochain network is fantastic because it eases adoption. I think for application developers, it's very important to try to reach customers and gradually migrate them over to these new technologies through the technologies that they're already using. And so I think that the WebSocket interaction piece with the Holochain network is brilliant, and that's definitely something that I would like to see in projects like Elastos. So imagine being able to communicate with a carrier network over a web browser. I think that would be extremely powerful, and I think that would be something that companies would be interested in. Other aspects like the shardedness of the DHT, so for example, the data is actually distributed amongst all the nodes that are running the application, I think is fantastic. I think that's a key to scalability. Now compared to something like Elastos, where you are using a proof of work based system, it does require a lot of gossip between nodes. And I think that that offers unprecedented levels of security compared to Holochain, where they kind of leave that up as an exercise to the application developer. So I think that Holochain is not, you know, it's definitely not a blockchain project. As a matter of fact, you could build a blockchain on top of the Holochain network, but it doesn't really lock you down as a developer. And I think that Holochain versus Elastos, I think they're catering to two separate sides of the market. So a lot of Holochain developers might want the freedom to be able to develop in different distributed network topologies, whereas Elastos, they're going to say, okay, here's the global carrier network, here is our blockchain or DID sidechain, here are the consensus mechanisms that it uses, whereas Holochain is just sort of like, here's kind of like a blank form, and here's the building blocks that you can put together in any way that you choose to sort of make it your own. It's very similar to like Objective-C versus Swift, whereas Swift allows you to do a lot more very quickly. Objective-C is very much, hey, it's a lot more granular, It's a lot more low level, but ultimately it's going to be a lot more powerful. So again, I think that both projects are fantastic. I think Holochain is really doing something great. They're very early. If you look on their GitHub, a lot of their stuff is pretty early. There's not a lot of watchers and stars and things like that yet. Definitely not compared to other projects, but they're really starting to gain traction. I'm definitely interested in seeing what they do with the holoports, specifically how they incentivize people to run applications on Holochain and how they deal with security and scalability. But so far, my review is definitely positive. Very big fan of that. Again, as we saw in the video, I'm definitely not a Rust expert. It should be noted that I'm not a Rust expert. So the code that you see is very much me learning Rust at the same time that I'm doing this video. And the HTML is intentionally very minimal. It's supposed to be very straightforward. I didn't use any advanced frameworks like Vue or anything like that because I want it to be as much about Holochain technology as possible. So yeah, I guess that actually wraps up this as day 2 in the 5 days of dApps or decentralization. So if you like what you see here, please feel free to smash that like button and smash that subscribe button and ask me any questions on Twitter or in the comments. We're definitely going to get back into some live streams. I've got some updates on the doorbell camera and some great things coming there. So stick around and I'll see you in the next video.